Good morning.
Good morning, ma'am.
Yeah, so here I've just enabled chat. So any queries you have, you can post in the chat box or unmute and ask. Okay. So here we go. We will be starting with continuing with current electricity. Okay, today is 13th June 2022. So you have an LED. You want this LED to light, right? You want to light the LED. So what are the steps that you are going to do? You have to light this LED. What all do you need? Yes, fast chat box or unmute. I'm waiting for your response. Yes. How do I light it? What all do I need? What all do I need? I need connecting wires. Yes, and then anything else do I need? A cell. Yeah, very good. Very good. So a cell. So what is the function of the cell here? I'm using a cell, okay, and I will connect the LED. This is the symbol for a diode. Diode. You have still not studied, so that's okay. So, and I need some connecting wires, and it's going to emit light. Fine. Okay, what is the purpose of the cell here? What is the cell doing? What is the function? It is, without that, can I light the LED? Waiting.
It's to induce a potential difference.
So it is the source of energy. Source of the energy. Which energy are we talking about? We are talking about electrical energy. Okay, so it is the source. Without that, the LED will not work. So what's again coming to sources? There are two types of sources. Electrical sources. Okay, one gives you a DC supply and the other is your AC supply. So we'll be, what is DC? Direct current. So we will be concentrating more on DC, and AC, maybe 6th chapter onwards, we'll be talking about AC. So right now it is all the direct current that we are talking about. So and your cell is a source of DC current. So cells is what we are going to in detail study about today. Can you tell me anything about AC? What are the components which work on AC? Any one component. I'm having something in the chat box. Source. Yeah, it's a power source. Yeah, correct. True, it's a power source. Yeah. AC, what? Give me one appliance which works on AC day to day. Any one appliance which works on AC. Is it in the chat box? I need to check. Okay, air conditioner, I think is what I have got the responses. Yeah, okay, good. Air conditioner. Yeah, anything. your refrigerator, your lighting in the house, the heating system in the house, everything works on AC. Okay. Again, I feel like asking one more AC question. What is the frequency on which all these appliances work? Just general question. What is the frequency in India? No? Okay. We will, of course, it is 50 hertz. So that's okay. We'll be studying in detail. It is 50 hertz. From 6th chapter onwards, electromagnetic induction. Okay, so we'll concentrate only on cells now. I'm just going to clear this. And so to understand more about all these things, we will, you need to know a few things. One is Ohm's law. Okay, what is Ohm's law? This we have done it all in our previous classes. V is equal to I into R. So the potential drop across a resistor, this is a resistor R, say current I is flowing through it. So this is the potential drop across the resistor, and this potential drop is equal to R into I. Okay, where R is a constant or temperature is a constant. Only when temperature is constant, resistance will remain constant. Otherwise, it varies. You have seen the thermal coefficient of resistance. Okay, we saw that in our previous classes. So then you should know that current flows from dash potential to dash potential. Means what? High and low. These two words you need to fill in. What are you going to fill in over here? Current flows from high or low? Current flows from high or low?
It flows from high potential to low potential.
Yeah, perfect. So this is going to be high potential to low potential. So if I have to calculate the potential difference, how will I do so? So I have here only I will take. So this is a region of high potential. So let us say that this is VA and this point is VB. This is low potential because current flows from high potential to low potential. So what is the potential V over here? So this is one more point you need to know. And the next is what you need to know is the potential difference. PD stands for potential difference. V is equal to V final, VB minus VA. Now this is a positive term or a negative term. Will this be positive or negative? In the example that I have taken over here, will this be positive or negative? Final minus initial. I have also told you that current flows from, yeah, VA will be greater than VB, right? Current flows from high potential to low potential. So you tell me VB minus VA, will it be a negative? Yeah, I got the answer. Very good. Negative. Yeah, very good. So potential difference, this potential difference is equal to, it will be negative. Can you tell me what this potential will be in terms using Ohm's law? So now V will be equal to a negative quantity, negative IR. Okay. Current into resistance. This I know. This is the current flowing through it and this is the resistance R. So this is what, these are all the points you need to know. Fine. Because all these days we were not using this negative sign. You used to say, okay, V is equal to I into R. But we need to be very precise. I'll tell you why this sign is so important. So we'll be studying that. So the first topic that we are going to see, of course, I told you we'll be studying about cells. Now, to understand cells, there are certain terms that you need to know. One is the EMF, and then is the terminal EMF. I can either use E or epsilon. This is the symbol. And then you have terminal voltage, which is terminal voltage. Whose symbol is capital V, and also you will be learning about internal resistance. internal resistance. Okay, so this internal resistance is small r. Fine. So now, further seeing now, I'll just share a link with you. You just get into that link. You also simultaneously, maybe I'll share the window. Um, so this is what you can use this link. I'll just post the link even in the chat box. So you have to open this window. Even you can open it, and you have to do it simultaneously along with me. So you could use this like that. So let me just construct a very simple circuit. I'm going to use a battery, of course, is very important. A cell is what we are studying now. And then I have some connecting wires here. I'll just connect a wire, and then again I connect it. Then here one more strip. You can keep doing it along with me. And I'm just going to use a light source here. Okay. And again connect this using the wire. Okay. So this is how you are going to connect the wires. Very simple. Okay. So now you see that the light glows. Why is it glowing? Because it is closed. Okay. So I just forgot to add in a switch. I don't know if I can just add in. Okay. I think I'll remove this, delete this, and I will put a switch in the circuit. Fine. So now you can see that the current has stopped flowing in the circuit. Why so? Because the switch is open. Okay, so the switch is open. So if I have to make things work, then I have to close the switch. Right? So then it will. So what are these black, blue things moving? What are those blue things moving? Yes, in the chat box, or you can tell me quick. Those are the electrons. Yes, those are the electrons which are moving. Um, So I can change here. You can see here, so conventional current. So it will be in the opposite direction. It moves from positive to negative. You can see the battery, this yellow side is positive and the black side is negative, and you can even see the positive terminal protruding out. So this is your positive and negative, it flows, right? So now, again, I open the switch, right? I take a multimeter. What is a voltage measuring instrument? A multimeter measures multiple things, but here it is a voltmeter, right? So I'm going to measure the potential difference across this positive and negative, fine? It gives me 9 volts. Now let us see. I say let there be some battery resistance, right? So I have set some battery resistance. Okay, so you will understand what it means. Now, when the circuit is open, you are getting this potential difference across the terminals of the cell. Now watch what happens. You close the circuit and look at this. The potential decreases. Fine, the potential decreases. Now you tell me, I made certain adjustments. Why do you think the potential is decreasing when I close the circuit? Any reason why the potential across the terminals of the cell is decreasing when I close the circuit? When I open the circuit, again, note, this is 9 volts. When I close it, it's 6.92 volts. Why so? Why is the potential across the cell decreasing? Okay, now what I do, I'm going to make this 0. Now the current is flowing. Now again I open, look at this, 9 volts. I close it, again it's 9 volts. Now can you tell me something why? It's okay, whatever you think you can tell me. What is this written over here? Battery resistance. So when I put this pointer somewhere here, fine, and it's showing something over here. It's showing 10 ohms. This is 0 to 10. So this will be 1, 2, 3 ohms, right? Look at this. It's becoming 6.92. Now, when I'm going to say it is 0 battery resistance, it's coming to 9 volts. Can you tell me why? Yes, anyone? No? Okay. Now, what happens is the cell itself is opposing the flow of current. Fine, that is why the voltage reduces. It is opposing to this 9 volts. So it reduces. Fine. This is because of the resistance of the cell itself. And this is known as internal resistance. What is internal resistance? Okay, so now I told you we need to study about EMF, terminal voltage, and internal resistance. Now, the higher voltage, okay, you got the higher potential difference across the cell. So that is your EMF. That is your EMF. So we'll see EMF. What is EMF? Now, can you define what is EMF? There is, I can see something in the chat. There is, 1 minute. Yeah, I'm unable to read the chat. I need to, internal resistance within the battery. Yeah, Aditi, yeah, the internal resistance within the battery. The resistance within the battery is known as internal resistance. Yes, you're right. So now, so EMF is nothing but the potential difference across the cell when no current is drawn from the cell, or there is no current in the circuit. No current is drawn from cell, or no current in circuit. In circuit, okay, or open circuit. Fine. So what is it? It's a SI unit. It's a potential difference. So it is volt. But look at this. What does EMF stand for? Electromotive force. So please don't say SI unit is force. No. SI unit is volt. It's the potential difference. Is it very clear to you? Now, what is terminal voltage? Terminal voltage is denoted by V. Can you guess what is terminal voltage? I have given you EMF. It is the potential difference across the cell when what? Can you complete it? You should be quick. When current is drawn from cell. Okay, current is drawn from the cell, or there is current in circuit. There is current in circuit or closed circuit. It's a closed circuit. Okay, again SI unit.
Are you sharing the board? I can only see the website, not the board.
Oh, 1 minute. What is this? Resume share. Can you see now?
Yes, ma'am, now it's visible.
Okay. Yeah. Thank you. Otherwise, I would have continued teaching like that only. Okay. Hope it is visible now. I'll continue. So SI unit is volt. Fine. Now we should see what is internal resistance. So with this, now I will be moving ahead. I'm clearing the board. Can I clear the board? Because this was not shared. Do I clear the board?
Yes, ma'am, you can clear it.
Okay. Fine. So I need to next define internal resistance. Now, one thing you can see is EMF and terminal voltage. You have to put the symbol less than, greater than, or equal to. What is the relation? Will EMF be less than terminal voltage? Will EMF be greater than terminal voltage, or EMF be equal to terminal voltage? Can you just tell me what is the symbol I need to put in? Yeah, anybody? So open circuit, what was the voltage? Open circuit. Open circuit. Can anybody recall? It was 9 volts. When you close the circuit, it was some 6 point something, children, I know, 6.7 volts. Okay, this is closed circuit. Means current is drawn. So what is the relation? What I should put over here? Less than, greater than, or equal to?
Greater than.
Yeah, of course, greater than. I could put equal to. When is it equal to? When small r is equal to 0. You saw that in open as well as closed circuit, you had 9 volts and 9 volts. When r is equal to 0, it was 9 volts. What is r? Internal resistance. Means the resistance offered by the cell or the electrolyte of the cell. What is r? R is the internal resistance of cell offered by the electrolyte. Okay. So in open circuit, there's no current. That is why you're getting high voltage. When you close the circuit, if internal resistance is 0, if it's offering very less resistance or very less, it cannot be 0, very, very less, then you'll get approximately 9 volts only. But if it is high, then it will be less than the EMF. Always point to be noted. EMF is always greater than or equal to, but in reality, EMF is always greater than V. But in some theoretical problems, they say that internal negligible internal resistance. So that time we take terminal voltage and the EMF to be of the same value. Okay, so now next we will see the relationship between the two. Exact. We just know now epsilon is greater than V, or EMF is greater than terminal voltage. Now we will see the exact relationship between this. So for that, I need to draw a simple circuit, and current is flowing in this direction, the same as I had drawn. So let this be VA and let this be VB. So VB minus VA, the same relationship I'm using, VB minus VA is equal to minus I into R. So this is the current flowing, this is the EMF, fine, and let it have an internal resistance of R. Now let us see all the potential drops in the circuit. First is this one. So as we move, there's a potential drop of minus IR here, okay? And also when we come over here, the current is moving from low potential to high potential, okay? Low to high. So final minus initial. Supposing, let us say that the battery is of 3 volts. Fine. So let us say this is 0 and this is 3 volts. So what is the potential drop across this? What is the potential drop across this final, and the current is flowing like this. Final is what? 3 volts. Initial is what? 0. So what is the potential drop? It is 3 minus 0 volts. 3 volts minus 0 volts. How much will it be? 3 volts. Yeah, 3 volts. It's a plus 3 volts because this is greater than this. So that is nothing but the epsilon. Okay. So I got minus IR plus epsilon, and also there is a potential drop because of the resistance in the same cell. Okay, and what is that potential drop? It is I into small r. I into small r. But look at this. Current always flows from positive to negative, but here it is flowing from negative to positive. So I have to take a minus. I is minus I. It is moving the other way around when from the conventional direction. It is opposite. That is why I take minus IR. So this is an other potential drop in the circuit. So totally there are 3 potential drops, and this is equal to 0. There's a law, okay, which we are going to study after this, but I'm using that law to explain that. What is the law? It is Kirchhoff's loop rule. It says that the sum of the potential differences in a closed circuit is equal to 0. Okay, in the closed circuit. So that's what I'm going, and this is very important. The signs which I have given is very important. It depends on the potential difference. Okay, whether it's going from low to high or high to low. Fine. So is this equation very, very, very clear to you? Because this is very, very important. So the moment you say, I'm clear, ma'am, I can continue. Yes, students, we are having only 4 minutes. If you can respond early, quick.
It's clear, ma'am.
Yeah, is it clear? Okay. So now we will continue further, rearrange the terms. You're going to get I into R. I into R is nothing but the potential drop here, because we are having only one component in the circuit, and the potential drop across this component will be the potential drop across this. Okay, so what is the potential drop across the cell when current flows through it? It is V, right? So this V is equal to I into R, right? So I can substitute IR as V. The sign will remain as it is, but it is equal to V minus V plus epsilon minus IR is equal to 0. So rearranging the terms, you'll get either epsilon is equal to V plus IR, or V is equal to epsilon minus IR. So both these equations are the same, but it depends on the numerical what you're going to get. So here it clearly shows that the EMF is greater than terminal voltage by a factor I into internal resistance, current into internal resistance. Is this clear? And the terminal potential is IR times less than IR. Yeah, you have to subtract IR from the EMF. Is this concept very, very, very clear? I will be clearing the board. Can I continue? Yes, children. Yes, ma'am. Okay, fine. We will continue. Now, I clear the board, and there are a few more equations which are okay. So we were seeing this. Um, epsilon equal to V plus IR, and then we were seeing I is equal to epsilon divided by R plus R. Now what is R? R is the external resistance and small r is the internal resistance. Now what is the maximum current that I can have? Two people are waiting, so admit all. Okay, so maximum current. So the maximum current that I can have is okay, I have actually an interesting question for you. Now I have this. This is a resistance R. So if I'm going to give you a graph, fine? So I'm going to plot a graph for the cell, and so I need a line. So this is the graph for the cell, right? Okay, and we are going to plot V versus I, fine? You are having V versus I, and you have this relation V is equal to epsilon minus IR. So you see that I is going on increasing along the x-axis. So as I increase I, okay, what will happen to V? Will it increase, decrease, or remain the same? I am increasing I. I'm increasing. Somehow I'm increasing I. I will tell you. You should tell me how I can increase I. Okay. But for now, okay, we are assuming that I is going on increasing over here. Maybe it is 0.1 ampere, then 0.2 ampere, then 0.3 ampere, so on. It is going on increasing. What happens to the voltage? Waiting for your response. Yeah, please.
Will it decrease?
It will decrease. Why? Because as I increases, the negative part of it also increases. So epsilon minus IR value will decrease. And look at the graph. It's going to be like this. Right? It's a straight line. Actually, I can use a straight line. Yeah, it's going to be like this, the graph. Fine. So now, important now, when I is equal to 0, see, this is the point where I is equal to 0, and see the graph where it is. So what is this value? Again, come to this equation. V is equal to epsilon minus IR. Now I is equal to 0. So what is V equal to now? Epsilon. What is epsilon? EMF. Correct? EMF. So comes back to the definition. When no current is drawn from the cell, then the potential difference across the terminals of the cell will give you the EMF. That's it. Fine. So look at this. And as you go on drawing more current from the cell, its potential difference, terminal potential, is going to go on decreasing. Okay, so I have a cell here. If I go on drawing more current from here, how will I draw more current? How can I draw more current? So this has some value of current I1, say. Okay, I'm going to put one more resistor in, say I'm going to put it in series like this. Okay, so what will happen to the value of the current? Will it increase or decrease? Will I increase or decrease? What will happen? What happens? I am putting one more resistance over here in series. Will I increase or decrease? Come on, children. R will?
I will decrease.
I will decrease because resistance is going to increase. Series resistance is going to increase. Fine. So I will decrease. The current in the circuit will decrease. But I am telling you, you have to draw more current from the circuit. When you draw more current from the circuit, the potential difference goes on decreasing. How can I draw more current from the circuit? By putting it in parallel. Correct. If I put this in parallel, then I'll be drawing more current because the resistance will decrease. Correct, no children? So I have resistance here. I have one more resistance here. Now the current in the circuit will increase. Why? Because resistance decreases. Because resistors in parallel is the resistance will decrease. It will become R by 2. Here it become 2R. Okay, so current will increase. Fine. So more and more, if I go on putting it parallel, it's going to go on decreasing, and I'm going to keep drawing more current. Okay, so what is the maximum current I can draw? What is the maximum current I can draw? What is the maximum? The maximum current I can draw is when there is no resistance at all. What is this condition? It has a special name. What is that name? Okay, I have no resistance. I just connect positive with the negative. What is this known as? Short circuit. What happens during short circuit? Huge current will flow. Actually, you should not be doing this. You'll be spoiling the circuit. It gets heated up, and you'll have you have chances of burning. Okay, so you should not be doing this. Okay, knowingly, unknowingly, you should not do it. It is very harmful. Fine. There are some students in the lab. They come to the socket. They will connect this socket using a wire. The whole thing gets burnt. Okay. So it is very dangerous. One thing is it causes damage, and then it is are there people waiting? Okay, admit all. It is very harmful, fine, and dangerous, and it's going to cause damage, everything. So please don't do anything like this in the labs or anywhere, even in your house. It's very dangerous. Okay, so this short circuiting means R is equal to 0, and the maximum current I can draw is now what does it become when R is equal to 0? Epsilon by R. So here external resistance is equal to 0. This is the maximum current I can draw from the cell. So when you draw the maximum current from the cell, its potential difference, there's no potential difference, is going to become 0, because you're joining positive to negative. The entire thing becomes 0 and maximum current flows. Right? So no more. So the external, but mind you, when you're talking about the external resistance, you get Ohm's law. This graph is for Ohm's law. Okay, the reverse. This is for external resistance. Now this graph is for the cell. It is giving, it's a source. Fine. So the more the current you draw, its potential, the terminal potential will decrease. Is that okay? Difference between external resistance and the cell, VI graph. Now there's one more topic, maximum power that I can get. Maximum power in the circuit. Okay. So we know P is equal to V squared by R. Fine. So it is seen that, and P max will be, P max is equal to dP by dR equal to 0. The value of R when dP by dR is equal to 0. Fine. So this is a small derivation. I'm not doing the derivation here, but I'll tell you for which value of R, if you go this way, you will see that R is equal to small r. So when the external resistance is equal to the internal resistance of the cell, you get maximum power in the circuit. 12 volts. If the internal resistance R of the battery is 0.4 ohm, what is the maximum current that it can draw? So just now we have seen the formula. Can anybody help me with the formula? Anybody help me with the formula?
Epsilon by R.
Yes, perfect. I max is equal to EMF divided by R plus R. So external resistance is equal to 0. So E is equal to 12 divided by 0.4. So what is the answer here? It will be 30 amperes. Fine. So we'll just now go through the important things, whatever we have done today. What are the different formulas? What is EMF? What is terminal voltage? You just tell me these two things and we will wind up. I will clear this. Okay, I'm clearing this. Okay, so now what is EMF? Yeah, what is EMF? What is terminal voltage? Quickly, children, we have 2 minutes left. Fast. EMF is the potential difference across cell when what? Dash. And terminal voltage is also potential difference across cell when dash. And the relationship V is equal to dash. Yeah, tell me fast. Options you want me to give? Potential difference when I equal to 0, or current is drawn from the cell. Current drawn or no current. Yes, one of the options for the two. In one case, current is drawn. In one case, the current is not drawn. Which one? Current, I can see something. No current. Yes, perfect. So when there is no current. Yes, or current, no current. Yeah. The other one, current is drawn. Potential, terminal potential. Now, what is the relationship between V and epsilon? V is equal to epsilon. Okay. Two options, epsilon plus or minus I into R. Choose one. Is it plus or is it minus? Epsilon. One new message. Yeah, epsilon minus IR. Epsilon minus IR. Perfect. And this is it. And we will wind up today's class. Any doubts? Okay. Thank you, children.
Thank you, ma'am.
Thank you.